So today we are going to discuss a new topic, and that is the shallow marine sedimentary environments. So we have already discussed that what are the sedimentary environments, and we have classified in the first lecture of the sedimentary environments that there are three types of sedimentary environments. Number one is continental, second is transitional, and third is marine. The continental sedimentary environments, they include the terrigenous as well as aqueous sedimentary environments such as the fluvial environment, deposition environment, glacial environment, desert environment. Then the transitional environment means those sedimentary environments which are located between the land and the ocean. If this is the land part and this is the ocean part, then all those sedimentary environments which are located between the land and the ocean, at this point they are known as transitional, such as delta, lagoon, tidal environments, beach environments, barrier complexes. So these are transitional environments. They are also known as marginal marine environments. Then the third is the oceanic environment or marine environment, and that is classified into two: the shallow marine environment and the deep sea environment. The shallow marine environment, that is up to a depth of, so today we are going to discuss the shallow marine sedimentary environment. Shallow marine sedimentary environments are those environments which lie into the ocean up to a depth of 200 meter depth. It means the 200 meter depth, that is the continental shelf, or that is the photic zone. So up to a depth of 200 meter into the ocean is the zone of shallow marine environment. In the case of shallow marine environments, as we have already discussed into the first part of the sedimentary environment, into the introductory part of the sedimentary environment, that the shallow marine environment or the continental shelf environment, from where the sediments will come from, and what are the processes, and what is the accommodation space. So the main source of sediment for the shallow marine environment are the continents. It means into the shallow marine environment there is substantial amount of sediments which are transported by various river systems up to the continental shelf region. So there is enough amount of terrigenous sediments, and that's why the shallow marine environment is again classified into two. Number one is the shallow marine terrigenous or terrigenous shallow marine environment. This terrigenous shallow marine environment is also known as clastic shallow marine environment. This is also known as sandy shallow marine environment. And the second is the carbonate shallow marine environment. So today we are going to discuss the terrigenous shallow marine environment or the clastic shallow marine environment or the sandy shallow marine environment. So what is the source of sediment? Continents are the source of sediments, and rivers, they are transporting the sediment from continental part to the continental shelf or the shallow marine setting. Then what are the various processes into the shallow marine environment, and what is the accommodation space? The accommodation space is the shallow marine environment, that is the continental shelf part, that is up to a depth of 200 meter into the ocean, and second is the epicontinental sea. The epicontinental sea, that is also known as Empiric Sea, means all those water bodies which are surrounded by land masses and are connected to the main ocean by a strait. What is strait? Strait is a narrow strip of water which connects two water bodies. So the epicontinental sea or the Empiric Sea, as well as the continental shelf of the ocean, they are the accommodation space for the shallow marine environment. The process, the source of sediment, the rivers, they are transporting the sediments from the continental part to the continental shelf of the open sea or the epicontinental sea. And then what are the processes which operate into the shallow marine environment? The main process into the shallow marine environment are: number one, tides, then waves, then storms, and then the ocean currents. So these are the various processes which transport the and deposit the sediments into the continental shelf or into the shallow marine environment. I have already defined in one of my lecture that deposition is nothing but that is the incompetency of any process or any sedimentary environment or any surface process to further transport the sediments. If the process is not capable of transporting the sediments, that process will deposit the sediment. So the wave and storms. Wave deposits, the storm deposits, the tidal deposits. These all are the wave deposits, the storm deposits and the tide deposits. These all are the deposits of clastic or terrigenous or sandy sedimentary environments. Some are deposited by waves, some are deposited by storms, some are deposited by tides, because these are the various processes. And the last I have discussed, that is the oceanic current. They are also one of the important processes. So these processes, they transport the sediments which are already transported by various river systems from the continental part to the continental shelf, and they also revert the sediments into the previously deposited continental part. So what is the function of wave? The wave deposits, because the wave that operate up to a level of fair weather wave base only. So the wave basically they deposits the sand like this. Huge amount of sand they are deposited like this, means in the form of sand ridges. And this surface of sand, which is 1 to 2 meter above the floor of the ocean, the maximum elevation that may be up to the sea level, they are characterized by ripple lamination. Sometimes they are also characterized by horizontal lamination. So the wave deposits the sand which are characterized by ripple lamination as well as they are characterized by the horizontal lamination. With the increase in the velocity of wave, the storm means high velocity winds, they are known as storms. So storms also they revolve the continental shelf sediments as well as they further transport the newer sediments, and the storm deposits are very well marked by the hummocky cross stratification. So basically the hummocky cross stratification I have already described the hummocky cross stratification in the sedimentary structures. So these are the hummocks. These are the hummocks, and then they are also characterized by the swells, and these are the hummocks. So the hummocks are convex up-like feature. This is a rounded mound-like feature which is few centimeter to a meter in height, Generally the wavelength is also 1 to 2 meter, and these round shape convex upward hummocks. Between two hummocks we may get the swells, they are the concave upward. So between the two hummocks there are swells, and this hummocky cross bedding or hummocky cross stratification, they are typical characteristics of the storm generated wave base. They are located between the fair weather wave base and the storm generated wave base. And all those deposition of sand which shows hummocky cross bedding, that is known as tempest-type bed. So tempest-type bed is the deposition of sand near the storm generated wave base, which is characterized by the presence of hummocky cross bedding. And in the case of hummocky cross bedding, the four set laminations, they are dipping in every direction. This is the characteristics of the four set lamination in the hummocky cross bedding, that they dip in every direction, generally at an angle of 10 to 20 degrees. So this is the characteristic feature of hummocky cross bedding, that their four set lamination, they dip in every direction at an angle of 10 to 20 degrees. So this is the hummocky cross bedding and the tempest-type bed, which is very typical characteristics of the storm generated wave base and are characterized by the storm deposits. Then second is the tide dominated cells. Tide dominated. So the first, in the case of shallow marine clastic sedimentary environment, is the deposition by wave and the storm. The wave, they form the sand, which are characterized by ripple lamination and the horizontal stratification. The storms, they are characterized by hummocky cross bedding and the swelly cross bedding. Then the tide dominated cell deposits or shallow marine deposits. What happens actually, the tides, which are generated, the rise and fall of sea water because of the gravitational pull of the sun and moon, the tide, they completely affect the deposition which have already taken place by the wave and the storms. So they affect, they modify the deposition which has already taken place into the continental shelf by the wave action as well as by the storm action. So the tide, they affect the wave and the storm deposits. And all the tidal deposits into the shallow sea, they are affected by the velocity of the tides. Generally the velocity of the tides, that varies from 50 to 150 meters per second. With the change in the velocity, the deposition of the tides, that changes. So if the velocity is very close to the 50 meter per second, then in that situation, 50 meters per second, then again the sand like this is formed, which are again characterized by the ripple lamination and the horizontal stratification. When the velocity of the tides that increases, and if the velocity that goes up to 50 to 100 meter per second, in that situation sand waves are formed. If the velocity is 50 to 100 meter per second, then the sand waves are formed. I have already described the sand waves in flow regime. These sand waves are also known as dunes. So if the velocity of the tide is 50 to 100 meter per second, the sand dunes are formed, and the migration of these sand dunes, they form the large scale cross bedding. Generally their height varies from 1 to 5 meter, and the wavelength that varies from 150 to 500 meter. So this is the height and this is the wavelength of the sand dunes. And their migration, they form the large scale cross bedding. The dunes, they form the formation of the large scale cross bedding. So the large scale cross bedding, if we are getting anywhere the large scale cross bedding, the large scale cross bedding means they are formed by the shallow marine environment. The large scale cross bedding, they can also be formed by the Aeolian environment, they can also be formed through the desert environment, but there is two main difference between the large scale cross beddings which are formed by shallow marine and the large scale cross bedding which are formed by the wind or which are formed by the desert system. Number one, if the large scale cross bedding is formed by the shallow marine system into the marine system, shallow marine environment, and this is by the desert. In the case of shallow marine environment, the foreset laminations generally they dip at an angle of about 60 degrees. Whereas in the case of desert, the foreset lamination they are inclined at an angle of 20 to 30 degrees. Generally, the Aeolians are 10 to 30 meter thick. They may be 100 meter thick in some situation. Whereas the large scale cross bedding which are formed by shallow marine environment, they are only few meters thick. So this is the main difference, the inclination of foreset laminations and the thickness between the shallow marine environment and the desert environment, the large scale cross beddings. Then if the velocity further increases, and if that is more than 100, and if that is between 100 to 150, then the sand ribbons are formed. Sand ribbons. This is like this. They are formed if the velocity is more than 100 meters per second, the velocity of tides. The sand ribbons are formed. They are few meter in thickness. They are 100 meters wide, and they are tens of kilometers long. That's why they are known as sand ribbons. If the supply of sediment is very low, then isolated ribbons are formed. And if the supply of sediment is very high, then the sand ribbons, the amalgamated sand ribbons are formed, and then they are known as sand ridges. So, if the supply of sand, the presence of sand ridges, they indicate that the supply of sediment is very, very high. And if the supply is low, then isolated ribbons are formed. With more than 100 velocity, if the velocity increases more than the 100, if that is around 150 meters per second, then the sand is completely washed out from that particular place, and then the sands or gravels in patches, they will be presenting to that particular region. It means, if we just look at the diagram, this will be the diagram, that here the sand surface, which is characterized by ripple lamination and the horizontal cross lamination, they will be present. Then with further increase in velocity, the sand ribbons will be present. With further, then here the sand dunes or sand waves, they are present. So if you just look at the schematic litholog for the transgressive sequences, for the storm, we will get like this, the lag deposits, then the hummocky cross bedding, and then the bioturbated mud. And for the tidal deposits, there will be again lag and then there will be large scale cross bedding, and then again there will be bioturbated mud. But this is for the transgressive sequence. So this is all about the shallow marine clastic sedimentary environment, in which there are three main processes: the wave, the storm, and the tides. And the fourth process, that is the oceanic current. They are basically such as Gulf Stream or Agulhas currents. We are familiar with a number of oceanic currents. So the oceanic current, they basically rework the sediments, and those sediments which are not in hydrodynamic condition, so they are known as the relict sediments, and the most important is the palimpsest. Palimpsest means all deposition of all those sediments which are relict as well as which are modern in nature. So the palimpsest sediments are the ocean current sediments. They are not very important in the shallow marine plastic sedimentary environment. Then we will have to discuss only the wave and storm deposits and the tidal deposit. So basically the shallow marine plastic sedimentation or sandy sedimentation means the deposition of sand of different sizes into the continental shelf by the wave, by the storm, and by the tides. So thank you and good wishes to all of you. In the next lecture we will discuss the shallow marine carbonate environment. Thank you and good wishes to